Hi guys, welcome back. Today we're going to be talking about the Kc value. Let's first just speak about what is the Kc value. So the Kc value is basically, we get it from a ratio of products to reactants. So at equilibrium is the concentration of the products over the concentration of the reactants, right? So remember the square brackets, they show that you are talking about concentration, right? What is the point of having the Kc expression or the Kc value? The Kc value is important because it gives you an idea of, in that equilibrium position, is it favoring the production, or is it favoring production of product, or is it favoring the reverse reaction, in the sense that does the equilibrium lie to the right, or does it lie to the left? So if you have more products, then it means that the equilibrium is going to lie to the right. If you have more reactants, it means it lies to the left, right? So if you look there, obviously concentration either in molar or mole per cubic decimeters over mole per cubic decimeters, right? So as you can see, concentration over concentration, so it means these are going to cancel each other out, right? So that's why we can say that a Kc value, which is the equilibrium constant, is unitless. It's unitless. That's why it is unitless, right? So it's concentration of products over concentration of reactants. Let's take an example. So before taking an example, let's actually just highlight some things that we do include in the Kc expression and things that we don't. So important thing is its concentration. So you can have a concentration of a gas, because in a gas there's a certain number of moles that occupy a certain volume, right? Remember, concentration is this, right? Number of moles per unit volume. So in a gas you have a certain number of moles occupying a certain volume. Same thing as in an aqueous solution, there's a certain number of moles in a certain volume of solution, right? So that's why when it comes to the Kc expression, we say that it's going to the states that we are able to include in the Kc expression are the gas and aqueous, right? Gas and aqueous, G and AQ, aqueous, AQ, aqueous solution, right? So those are the states that we do include in the Kc expression. What we don't include is the solid as well as the liquid, right? Now, if you look at your Kc expression, let's now quickly make an example. Let's say you are given the formation of ammonia, right? Equilibrium reaction, and let's say it forms NH3 and delta H is less than 0, right? Okay, let's quickly balance that, and it's balanced now, right? So all of these are gases. All of these are gases. How would you write the Kc expression? Again, concentration of the products over reactants. So my products would be the NH3. Then when you write the Kc expression, you write the concentration, and the exponent is the mole ratio. You use the mole ratio to write the exponent. So it's the concentration raised to the mole ratio. So that's going to be to the exponent of 2 over concentration of N2, right? Since there's no number here, it means it's 1. So I'm not going to have any number on the exponent. It's to the exponent of 1. Then H2 is going to be to the exponent of 3. Yes. That would be the Kc expression. Then another important thing to remember is that the Kc expression or the Kc value rather is only affected in grade 11 and in grade 12. We only deal with it being affected by temperature. So Kc value affected by temperature, right? So we only deal with the effect of temperature on the Kc value. Then the question becomes, how do you know whether the Kc value is going to increase or is it going to decrease? What is going to happen? How do you know that? You know it by checking the type of reaction you have. Is it a reaction that is exothermic or endothermic? So in this instance, since I'm given delta H is less than 0, it means the forward reaction is exothermic and the reverse is endothermic, right? So for instance, when we're doing factors that affect equilibrium, then you know that temperature is one of the factors that do affect the equilibrium. So decrease in temperature favors the exothermic reaction, while an increase in temperature favors the endothermic reaction. So remember Le Chatelier's principle: to absorb the heat, the endothermic reaction would be favored when you increase the temperature, right? So how does the Kc value get affected? For instance, if I make a change like a decrease in temperature, which is going to favor the exothermic reaction, then what is going to happen? In this instance, the forward reaction is favored, right? So a decrease in temperature is going to favor the exothermic reaction, right? In this reaction, you must specify it would be the forward reaction that is favored, right? Then, when the forward reaction is favored, how does it affect the concentrations? That's the important thing, right? So if the forward reaction is favored, then it means this concentration of NH3 is going to increase, and then the concentration of N2, the reactants, is going to decrease, and H2 is going to decrease. This is going to increase, right? So imagine before you had 2 over 1, right, which was giving you 2 when you have done all your values here. Now if you increase this one, let's say you increase it to now 4, and this one is decreased to 0.5, then what is happening here in this instance is that you're going to have a higher Kc value than before, right? So I'm just putting values to put you into a bit of perspective, right? So it's a fraction. If you increase the numerator and you decrease the denominator, it means the value that you're going to get at the end is going to be bigger than before, right? So that would mean in this instance the Kc value would increase. The opposite is also true, because if you favor the endothermic reaction, then it means the concentration of the products is going to decrease. The concentration of the reactants is going to increase. That means overall what is going to happen? It means the Kc value would decrease, right? I hope that video was very helpful to you understanding the Kc value. If you found it helpful, please share with anyone and everyone that may also find the video to be helpful. Please subscribe if you haven't already, and I'll see you on the next video.